Hello and welcome to Math 131. This video will be the second half of week 2's lesson. So we'll go over creating, editing new variables and categorical variables. Now, what we're going to start doing in this section is talking about categorical variables. And we're going to introduce how to create and edit new variables in a pandas data frame by first creating a new numerical variable. And then from that, we will create a new categorical variable where we change the labels of the categorical variable. This will encapsulate most tools you need for creating and editing new variables and following up dealing with categorical variables. So let's get started. We're going to continue to use this msleep data frame from the plot9 library. We're going to go through this column and we're going to take out the column brain weight. So remember that you can extract just a single column from a pandas data frame, almost like the pandas data frame is a Python dictionary, and you can get the column out. Now we're going to do that to get out the column brain weight, but then we're also going to extract the column body weight, and then we're going to divide these two columns. Because these two columns are both the same size, they are both 83 rows, even though some have nans, that's okay. We can divide the two, and when we divide two columns like this, it will act element-wise. So the 0th row of brain weight will be the numerator over the 0th row of body weight in the denominator. And then separately, the first row of brain weight will be the numerator over the first row of body weight. And it will do this element-wise throughout the entire column, such that we get out a new column of exactly 83 rows, where it's taken each row from each of the two columns and divided them. So now that we have a new column of exactly 83 rows, we can actually index into the msleep data frame by a column name that did not previously exist and assign to it. That is very much like the behavior of a dictionary in Python that we saw before. You can, with square brackets, index into a data structure with a key that does not exist and insert into it a new column such that that new column has the same exact number of rows as the data frame. So I'm just going to print now here the exact column we had before, but you can see because I assigned it into the column brain body weight, I can now ask from the data frame msleep for that column, and I get out exactly that. So right there, I have created a new column from a mathematical operation of two other columns. And just like we saw before, we can describe this new column however we want. So we can count the number of actual data we have in this new column. We can get a mean, mins, maxes, and the third quartile here. That number is going to show up again later on for us. So let's just move on with another way to create a new variable. Now previously we created a new numeric variable, but now let's go ahead and start working towards creating a new categorical variable. So this is a new variable that is not numbers. So I'm going to create a new variable named smart, SMRT, and I'm going to assign it the single value false. This is a bit tricky because this doesn't really look like what we did above. Above, we created a new variable, brain body weight, in the data frame msleep by inserting into it a column of the appropriate size. Now this code down here on the right-hand side does not have a column of appropriate size. It's just a single value. And yet, pandas knows the size of msleep. So what it will actually do is copy this value false as many times as necessary to fill out a new column. Let's just look at that so we can see what those crazy words mean. This line of code here creates a new column in the data frame mSleep named smart, and it fills the entire column with just falses all the way down. So that is allowed, albeit a little tricky code right off the bat. So what we're going to do is create a new categorical variable. We're going to fill the entire thing with falses, and then we're going to pick out very specific rows of this column, and we're going to make them true. Since our variable is smart, we're going to ask for brain body weight greater than or equal to 0.015. Now that's where that number came back from. If you look here, that's me rounding the 0.015 to 3 decimal places. I'm effectively saying, let's try to create a new variable smart, where we're going to call an animal smart if their brain to body weight ratio is greater than the value that puts 75% of the animals less than it. Let's say that another way. Only 25% of animals have a brain to body weight ratio greater than 0.015. Well, there's only 25% that have a brain to body weight ratio greater than 0.015 because 75% of the animals have a brain to body weight ratio less than this number. So here I'm doing a little bit of phrenology where I'm going to claim that brain to body weight ratios makes for smart animals. It's probably not exactly true, but I think it is a fun and silly example to help us understand how to create a new variable, new categorical variable. So I'm going to name this smart index, and here is now a variable of Boolean values. Anywhere an animal has a brain to body weight ratio less than 0.015, it'll be written as false. And anywhere an animal has a brain to body weight ratio greater than or equal to 0.015, it will show up as true. So now we have this Boolean index for which we can access just the specific rows that are true for the column smart and assign those to the value true. And so what we've done is singled out all of the animals that have a brain to body weight ratio greater than or equal to 0.015. And we've changed only those values to hold the Boolean value true. And since smart IDX is false wherever they are less than 0.015, it just left those values as false. And so here we've created a new categorical variable because it doesn't have numbers, named smart. And it indicates to us which animals in our data frame appear to be smart by this made-up criteria. So that's great. We have this new column, but maybe these aren't the labels that we want. Maybe we'd like to be able to change those labels. There is a type specific to the pandas library named category. So if we go mSleep smart dot as type category, we can literally change the data type of the column smart to the type category. Now this is the code that will change the type, but if you run it just like this, it's going to change the type of the column smart, print it out for us, and then never store it back in the data frame. So what we actually need to do is overwrite by assigning back into the column of interest the change that we're interested in. And this will change the data type of the column smart. We still haven't gotten the labels that we wanted, but at least we've changed the data type of the column smart so that we can use it as a type category to change the labels that we want. So we'll go mSleep column smart, treat it as a categorical variable because we now know it has the appropriate data type for that, and we will rename categories. We're going to pass in a dictionary to this function, rename categories. We're going to say anywhere it was false, we want to name that nope, not smart. And anywhere it was previously true, we want to put a label on that of yup, smart. And same thing as before, this whole line of code will make the change on the column smart, print it out for us, but not store it back into the data frame like we want. So in fact, we need to overwrite the column smart once again. And then we will print to see that our changes indeed went into effect. We have now changed all falses to nopes and all trues to yups. So maybe as like a quick comment, we can say old to new, and hopefully that makes sense. The dictionary we pass into the function rename categories takes as keys the old value and uses values that are the new value. So previously we had falses and trues, and we're going to change all the falses to nopes and all the trues to yups. Now let's see if we can extend our binary categorization to something more. So we're going to take from our data frame the column smart, treat it as a category, and add categories meh and do. And we'll repeat the same pattern as before, where we make our change on the variable of interest, and we'll assign that back into the variable we're trying to change. So now we've got these two new categories added to our column smart, and what are we going to do with them? Let's create a middle ground between smart animals and not smart animals. We'll call the middle ground meh. They're just something in between the smart and not smart animals. We'll go any animal with a brain to body weight ratio that is greater than or equal to 0.004. Let's mark them as true. So this is like a Boolean index like we've seen before. But we're going to create a middle ground, something between 0.004 and simultaneously less than the cutoff we had above for smart animals. So these two numbers, 0.015 and 0.004, they came from our summary of the brain to body weight ratio above. So here's the 0.015 like we saw before, the cutoff at which 75% of animals have a brain to body weight ratio less than this value, and 25% have a brain to body weight ratio greater. And here's my 0.004 rounded to 3 decimal places. This is the cutoff that puts 25% of animals less than this value and 75% of animals greater than this value. So effectively, in between 0.004 and 0.015 is 50% of the animals. So our meh middle ground is going to be the middle 50% of animals where they're not particularly smart, but they're not particularly dumb. And this code here is going to find for us whoops, that's my typo right there. Took me just a second to see it. Errors happen to everyone. You just gotta kind of read through the code, suffer through it, and figure out what's wrong. This code here is going to find for us all the rows of animals for which they are appropriately in this middle grouping. They have a brain to body weight ratio greater than 0.004 and less than 0.015. This is going to be our new meh index. And like before, we can use this index to take the locations of the meh index and the column smart and assign the label meh. So now we have the column smart which has nopes, yups, and mess, just as we'd hoped for. But if you look back at our code, I actually previously added the category dough. Well, I did that on purpose, but you could imagine it could happen by mistake. And if you want to get rid of unused categories, there is a built-in function for the column of interest. You treat it as a category, and you remove unused categories. And same pattern as before, assign that back into the column of interest. And we have what we want. We now have no unused categories because we've removed them all, and we have our more than just binary labels. We now have the extra labels meh. So now you can see how to create and change the labels of categorical variables.